Hello everyone. Today we will learn binomial theorem related to JEE Mains and Advanced. Before going to this lecture, make sure that you have watched the binomial lectures I have uploaded in our channel. So let's continue. Today we will mainly see various types of problems that may come in your exam, JEE Mains and competitive exam. So see, these are first type of problem, counting rational or irrational terms. So this is a recent question, JEE Mains 2019. The total number of irrational terms in the binomial expansion of this thing, 7 to the power 1 by 5 minus 3 to the power 1 by 10 whole to the power 60. So in order to find out the irrational terms, always remember, first of all you have to find the rational terms. Then subtract from the total number of terms, you will get irrational terms. Never find out irrational terms at the first attempt, because in maximum cases irrational terms will be larger or higher than the rational terms. So see, this is the binomial expansion given. So in this we know that total number of terms is n plus 1, that is 60 plus 1, that is 61. Now first of all find out the general term, that is tr plus 1 ncr a to the power n minus x to the power n minus r a to the power r. So let us say this is our x and this is our a. So x to the power n minus r into a to the power r. A is minus because we have used the general term as x plus a whole to the power n. So our a is minus 3 to the power 1 by 10. Remember this. Now see, simplify here, 60 cr, this is 7 to the power 60 minus r by 5, this is 3 to the power r by 10 and into minus 1 to the power r. In order to make this general term as rational, because we want to find out the rational terms, so see, 60 cr, this term is always integer, so we don't have to worry about this thing. Now look at this term, 7 to the power 60 minus r by 5 and 3 to the power r by 10. This is only this only gives your sign, so we don't have to worry about that. We have to calculate only these two terms. In order to calculate the rational terms, this term should be rational and this term should be rational individually. In order to become this term, in order to make this term rational, 60 minus r by 5 should be your integer, so that 7 to the power some integer value would be a rational term. And 3 to the power r by 10 to be a rational term, r by 10 should be an integer. So r by 10 should be an integer and 60 minus r by 5 should be an integer. Now see here 60 cr, that means our r, range of r is 0 to 60. So our r can take value from 0. See, r can take value from 0 to 60. So r is integer, r is integer, right? So r can take value from 0 to 60. So in order to make r by 10 integer, r should be a multiple of 10, and in order to make this thing integer, you can divide by 60 by 5, that is 12 minus r by 5. So r by 5 to be an integer, r should be a multiple of 5. See, r should be a multiple of 10 and r should be a multiple of 5. So you have to take the common thing, that is r should be a multiple of 10. So r can take value from 0 to 60. So 0, 10, 20, 30, 40, 50, 60. So only 7 value is for rational terms. So our total number of terms is 61. So 61 minus 7, that is 54 terms are irrational. So the answer is 54 terms. Let us see some theories related to binomial coefficients, which we have not learned in our board level lecture. So sum of binomial coefficients, sum of all binomial coefficients, that is NC0, NC1 up to NCn, is here 2 to the power n. Sum of binomial coefficients whose lower suffix is even, that means even suffix, coefficients of even suffix, that is 2 to the power n minus 1, and odd suffix is 2 to the power n minus 1. See, if you add these two terms, 2 to the power n minus 1 plus 2 to the power n minus 1, that means this thing plus this thing, you will get the this whole series. Okay, so 2 to the power n minus 1 gets common, 1 plus 1 is 2, that means 2 into this, that is 2 to the power n minus 1 plus 1, that is 2 to the power n. You will get 2 to the power n. Now remember these two formula, NCR plus NCR plus 1 is n plus 1 CR plus 1, and NCR plus n. So NCR plus NCR minus 1 is your n plus 1 CR. And remember this thing, KCK plus K plus 1 CK, K plus 2 CK up to K plus n CK is your K plus n plus 1 C K plus 1. See, let us see an example, 2C2 plus 3C2 plus 4C2 plus 5C2 up to 6C2. So you can write it as, see, KCK, that is 2C2 plus 2 plus 1C2, 2 plus 2C2, 2 plus 3C2, 2 plus 4C2. That means our n is 4 here, right? So K plus n, that is 2 plus 4 plus 1, that is 7, and here 2 plus 1, that is 3. So your answer is 7C3. To remove R when present in multiplication, you have to remember this formula, R into NCR is equals to n into n minus 1 CR minus 1, and when it is in division, if you want to remove the R terms, that is NCR by R plus 1 is your n plus 1 CR plus 1 by n plus 1. Now let us see what is binomial series. Binomial series is nothing but multiplication of two binomial coefficients. So when two binomial coefficients are present in multiplication, that is see, NC0 into NC0, NC1 into NC1, NC2 into NC2. So this formula is 2NCN, and NC2, NC3, NC3, NC4, NC4, NC5, NCN minus 1, NCN. This is your 2NCN minus 1 minus NC0, NC1 plus NC1, NC2, because if you noticed here that we have omitted two terms, those two terms should be subtracted from this formula, 2NCN minus 1. So let us see some theorems. So multiplication theorem is x plus y plus z. If we have three terms to the power n, you can apply this general formula, n factorial summation of n factorial by a factorial, b factorial, c factorial, x to the power a, y to the power b, z to the power c. But remember, a plus b plus c should be your n. Now if we increase another term, x plus y plus z plus t to the power n, then one term will increase d, here t to the power d. Here also the same logic. That means a plus b plus c plus d should be equals to n. So this is very important. Now in order to find remainder, let us see one problem which came recently, JEE Mains 2020. If fractional part of p, this is known as fractional part, within second bracket something written, that is known as fractional part. So if fractional part of p denotes the fractional part, then this fractional part of 3 to the power 200 by 8, you have to find out the fractional part of this thing, 3 to the power 200 by 8. Now see, 3 to the power 200 we can write it as 3 square to the power 100. 3 square is 9, and 9 we can write it as 8 plus 1 to the power 100. Now apply binomial theorem. Here one term is 1, so NC0 x to the power n, NC1 x to the power n minus 1, NC2 x to the power n minus 2 up to NCN x to the power n minus n, that is 0. Now see, if you take 8 common from this whole term, so you will remain with, see, NC0, NC1, NC2, all these terms are integer. So if you take 8 common, you will get integer here, and this 100C 100 means 1, right? NCN means 1. So 100C 100 is 1, so we will get 1 as a remainder. Now what is the property of fractional part? See, if we have I plus alpha within fractional part, so our answer would be integer is omitted. Let us say I is integer. Integer you can omit it because it will not count in the fractional part, so our answer would be fractional part of alpha. Now here you see we have integer, right? So in this term can be 3 to the power 200 is written as this, 8 into I plus 1 divided by 8. So within fractional part 8 into I plus 1 by 8. This 8 is cancelled out, so we have integer plus 1 by 8. So integer part is omitted from this theorem, we can say integer part is omitted. So we will remain with fractional part of alpha. So integer part is omitted, so we will remain with fractional part of 1 by 8. So what is the fractional part of 1 by 8? It is 1 by 8, right? It is 1 by 8. So our answer would be 1 by 8. Now if you want to use binomial theorem for any power, see we already know this formula, NC0 NCR x to the power n minus r a to the power r. From the general term you can apply binomial theorem, but remember this thing in order to solve it very quickly. 1 plus x to the power n is 1 plus nx plus n into n minus 1 by 2 factorial into x square n into n minus 1 n minus 2 by 3 factorial into x cube, and in this formula remember mod of x is less than 1 and n is rational number. Now we will see some problem. So middle term, let us see the middle terms, though we have learned it in our board level lecture. Let us see more in depth in this lecture. If n is even, we already know if n is even natural number, there will be one middle term, and if n is odd natural number, there will be two middle terms. And for x plus a whole to the power n for this expansion. So what would be the middle term for if n is even natural number? The middle term would be t n by 2 plus 1th term, t n by 2 plus 1th term. So if you take LCM, the middle term would be for t n plus 2 by 2. So here t r plus 1. So that is our general term. So r is n by 2. So we know the formula NCR x to the power n minus r into a to the power r. So you will get middle term as NC n by 2 into x to the power n by 2 into a to the power n by 2 when there n is even natural number. And if n is odd natural number, there will be two middle term. One would be n plus 1 by 2 2th term, and another would be n plus 3 by 2th term. So in order to apply our general term, that is t r plus 1th term, so what we have to do, we can make it as n by 2 minus half plus 1. So minus half plus 1 is plus half. So this term can be written as this thing. So our r is, if you take LCM, n minus 1 by 2. So this is our r now. This is our t r plus 1th term. Similarly, you can make this as also n plus 1 by 2 plus 1. You can make this t r plus 1th term as n plus 1 by 2 plus 1. So if you take LCM, n plus 1 by 2 plus 2, that is 2 plus 1, that is 3, that is n plus 3 by 2. So there will be two middle term. One would be t n minus 1 by 2 plus 1th term, and another would be t n plus 1 by 2 plus 1th term. So for this thing our middle term would be NCR, that is NC n minus 2 n minus 1 by 2 into x to the power n minus r. So n minus 1 by 2 x to the power n minus n minus 1 by 2, if you calculate you will get n plus 1 by 2 a to the power r, that is a to the power n minus 1 by 2 would be our one middle term, and another would be from this thing, that is NCR that is n plus 1 by 2 x to the power n minus r. So n minus of n plus 1 by 2, you will get n minus 1 by 2 and a to the power n plus 1 by 2. See here just the thing is reversed. If you have n minus 1 by 2 here, you will get power of x as n plus 1 by 2 and power of a as n minus 1 by 2. And if you have n plus 1 by 2 here, you will have n minus 1 by 2 as x power and n plus 1 by 2 as a power. So you can remember like this also. And remember, this is very important, binomial coefficient of middle term is the greatest binomial coefficient, because after we know, if you see the general formula, if you say the general formula t r plus 1 formula, that is summation of r equals to summation of NCR x to the power n minus r a to the power r. So after middle term, this term will get reduced. So our middle term would be the greatest binomial coefficient. One question can be formed from this logic. It means NCR will be greatest if r equals to n by 2, that is if n is even, right? And NCR will be greatest if r equals to n minus 1 by 2 or n plus 1 by 2. See, if r equals to n minus 1 by 2 or n plus 1 by 2, that is for odd terms. Okay. So remember this, we will solve some previous year question. So let us see one problem to greatest middle term. If n is even positive integer, then the condition that greatest term in the expansion of 1 plus x to the power n may also have the greatest coefficient. This problem came in WBJE 2018. So see, in the last slide just we have seen that if n is even, then n by 2 is the greatest coefficient in 1 plus x to the power n. This thing we have already seen. And what is the greatest term? Greatest term would be n by 2 into x to the power n by 2, because we have 1 here. So see, if n by 2 is the greatest term, so that means we can say that n by 2 into x to the power n by 2 should be greater than n by 2 minus 1 into x to the power n by 2 minus 1, and n by 2 into x to the power n by 2 is greater than n by 2 plus 1 into x to the power n by 2 plus 1. This is very simple, right? If n by 2, that is the middle term, if this middle term is the greatest, then that means the less than that middle term and greater than that middle term would be less than that middle term, that means n by 2 minus 1 should be less than this thing, and greater than that middle term will also be less than that middle term, because middle term is the greatest coefficient. So we can compare something like this: n by 2 into x to the power n by 2 is greater than n by 2 minus 1 into x to the power n by 2 minus 1, and n by 2 into x to the power n by 2 is greater than n by 2 plus 1 into x to the power n by 2 plus 1, as n by 2 is the greatest term. So less than that term and greater than that term, both of them will be less than n by 2. So solve this. In order to solve this, you remember one formula. This is extremely important formula. NCR by NCR minus 1 is your n minus r plus 1 by r. We will apply this formula. See, NCR by, if we divide by NCR minus 1, so NCR by NCR minus 1 will be n minus r. So n is n minus r, r is n by 2 plus 1 divided by r, n by 2. So calculate. So in that term, if we divide by x to the power n by 2 divided by x to the power n by 2 minus 1, so it will be x to the power n by 2 minus, it will be in the upper side, so n by 2 plus 1. This is cancelled out, we will have only x in the left hand side, that should be greater than 1. Now x should be greater than n by 2 by n by, if calculate this, you will get n by 2 plus 1. So simply LCM, take LCM and simplify, you will get x is greater than n by n plus 2. And from this thing you can say that n by 2 plus 1 divided by n by 2, now compare with this formula, NCR divided by NCR minus 1. So n by 2 plus 1 minus 1 is n by 2. So our r is n by 2 plus 1. So n minus r plus 1 divided by r into, if you divide by x to the power n by 2, x by n by 2 will cancel out, you will get x here. So 1 is greater than this thing. Now simplify, n by 2 plus 1 divided by, you will get here n by 2, n by 2 plus 1 divided by n by 2 should be greater than x, and x is, so we can conclude that x is less than n by 2 plus 1 by n by 2. So x is less than, simplify this, you will get x is less than n by 2, n plus 2 by n. So from this we got that x is greater than n by n plus 2, and from this we got that x is less than n plus 2 by n. So x lies within n by n plus 2 and n plus 2 by n. N by n plus 2, what is the option? N by n plus 2 and n plus 2 by n. So option A is correct. So let us see another problem. See, if C0, C1, C2, C15 are the binomial coefficients in the expansion of 1 plus x to the power 15, then find the value of this. C1 by C0 plus 2 into C2 by this up to 15 into C15 by C14. This problem came in WBJE 2020. Now see, let us see the general formula for this. So let us see NC1 by NC0 plus 2 into NC2 by NC1, 3 into NC3, because we can see that whatever is in the suffix here, we will that term is in the outside with multiplication. So 2 into NC2 by NC1, 3 into NC3 by NC2, and in the last we can say that n into NCn by this is 1 less than this thing, so n minus 1. So n into NCn by n into NCn by NCn minus 1. Now see, divide this thing, use the formula, right? We have already learned in the previous problem that NCr by NCr minus 1 is your n minus r plus 1 by r. So apply same formula for here, you will get n by 1. Apply same formula here, you will get n minus 1 by 2. Apply that same formula here, you will get n minus 2 by 3, and in the last you will get 1 by n. See, this 1 by n cancel out, this 3 cancel out, 2 cancel out. So from this you can say that n plus n minus 1 plus n minus 2 up to the series will go to up to 1. So if you reverse this series, you can see that the series start with 1 and it goes to n. So sum of n natural number we can say, and that is n into n plus 1 by 2. Or there is a AP series with first term 1 and last term n. So we know the formula n by 2 into first term plus last term, so 1 plus n. We will get the same formula, n into n plus 1 by 2. So from this we can say that if you compare this series with this series, we can say that here we have only 15 here, right? Up to 15 term, it is given. So our answer would be 1 by 2 into 15 plus 1, that is 16, that is 120. So let us see another problem. The coefficient of a cube b to the power 4 c to the power 5 in the expansion of this. See, in today's lecture we have already seen that multinomial theorem, multinomial series. So multinomial series, from multinomial series we know if it is a plus b plus c to the power 6, then we can break it as r something, let us say we have break it out at r s t, and we know already that r plus s plus t should be equals to 6, and here we have n factorial by r factorial s factorial t factorial to the power ab to the power r, bc to the power s, ca to the power t, let us say. So arrange all the related terms in one thing, that is a to the power r into a to the power t, that is a to the power r plus t, b to the power r, b to the power s, that is b to the power r plus s, c to the power s, c to the power t, that is c to the power s plus t. Now see, in the general term it is given that they want the coefficient of a cube b to the power 4 c to the power 5. So a cube b to the power 4 c to the power 5. So compare with this. So r plus t should be equals to 3, r plus s should be equals to 4, s plus t should be equals to 5, and we already know r plus s plus t should be equals to 6. So solve the equation, you will get r equals to 1, s equals to 3 and t equals to 2. So what would be the coefficient? Coefficient would be this thing, 6 factorial by 1 factorial, s is 3 factorial, t is 2 factorial, this thing. And now this is 6 factorial by 2 factorial into 3 factorial, but in the option there is nothing like that. So let us see this option. So here we have 3 factorial. So in order to get 3 factorial here, we have to multiply it by 3 and multiply it by 3. So 3 into 2 factorial, that is 3 factorial and 3. So our option is option D. Now let us see another problem. The remainder when this thing 7 to the power 7 to the power 7 to the power up to 22 times 7 is divisible by 48. Now see, this thing 7 to the power 22 times 7 can be written as 7 to the power 2m plus 1. Now 7 to the power 2m plus 1 is 7 to the power 2m into 7 to the power 1, that is 7 into 49, 7 square is 49, 49 to the power m. Now 49 can be written as 1 plus 48 to the power m. Now apply binomial theorem, that is NC0 into a to the power 1 n minus 0 into b to the power, let us say b to the power r. So 48 to the power 0 is 1, 1 to the power something 0, NC0 is your 1. So from first term we will get 1, and in the second term it would be NC1, this 1 to the power something will gone, right? So this will be 48 to the power 1. So all the next terms, all the subsequent terms will contain 48, and in the first term we will contain 1 only. So when 1 multiplied by 7, 1 multiplied by 7 would be 7, and all these thing have contained 48. So if you take 48 common, in the bracket, we will, let us say we got some integer k. So 48 multiplied by k. 48 multiplied by 7, that is k into 7, also you can take it as 7, 48 k. So 48 multiplied by k plus 7. So what is the remainder? Remainder is 47, because if you divide by 48 here, 48 cancel out, 7 by 48, so remainder is 47. So option is B. Option B. So I hope all of you are enjoying our videos. Please like, share and subscribe, and let's target 200 likes. If I got 200 likes, we will upload more previous year problems related to binomial theorem for JEE Mains and Advanced. All the best. Thank you.